Hi learners! Welcome to Math is Fun with Sir O. Today, I will be discussing statistics. Standard normal distribution is the third subtopic under our lesson on statistics. Let's go to our learning outcomes. At the end of this lesson, the learners will be able to first, recognize the normal and standard probability distributions and apply them appropriately. Second, know how to get the area of z-value or z-score. Third, familiarize and learn how to use the standard normal distribution table. And lastly, learn how to represent the z-values and its corresponding area using graphical representation. One of the most important statistical distributions of data is known as the normal distribution. The shape and position of the normal distribution curve depends on the two parameters, the mean and the standard deviation, which normally distributed variable has its own normal distribution curve, which depends on the values of the variables, our mean and the standard deviation. The larger the standard deviation means it is more dispersed or spread out the distribution becomes. We have here the properties of normal distribution. First, the distribution curve is a bell-shaped. As you can see in the picture, this is our normal distribution curve. It is a bell-shaped, and sometimes it looks like a mountain seen from the distance. Second, the curve is symmetrical about its center. If you're going to draw a straight line from the top going down at the center of our normal distribution curve, we can see that the left side is symmetrical to the right side. Third, the mean, median, and mode coincide at the center. So we can find our mean, median, and mode here at the center. Fourth, the tails of the curve flatten out indefinitely along the horizontal axis but never touch it, or the curve is said to be asymptotic to the baseline. As you can see in the picture, it seems like the tails of our normal distribution curve are touching our horizontal axis. But in reality, if you're going to zoom in at the tails of our normal distribution curve, they are not touching our horizontal axis. They never do. And last but not least, the area under the curve is equal to 1. Thus, it represents the probability proportion or the percentage associated with specific sets of measurement values. So the total area of our normal distribution curve is equal to 1. In percentage, that would be equal to 100%. In other words, at the tip of the tail from the left side of the normal distribution curve to the tip of the tail on the right side of your normal distribution curve, the total area is equal to 1, or that is also equivalent to 100%. The empirical rule for a normal distribution. In a normal distribution, approximately 68% of the data lie within one standard deviation of the mean. The shaded region in blue color here in our picture constitutes one standard deviation of the mean where our 68% of the data were. Next, 95% of the data lie within two standard deviations of the mean. So that would be the shaded region in yellow on the left side, including our blue in the middle, and yellow color on the right side constitutes two standard deviations of the mean, where our 95% of the data were. And lastly, 99.7% of the data lie within three standard deviations of the mean. So the shaded region on the left side in pink, the yellow, the blue in the middle, the yellow on the right side, and the pink on the right side constitutes three standard deviations of the mean, where 99.7% of the data were. How to find the area under the normal curve given a z value? First, express the given z value into a three-digit form. Second, using the standard normal distribution table, find the first two digits on the left of the column. Third, match the third digit with the appropriate column on the right. And lastly, read the area or probability at the intersection of the row column. So this is our normal distribution table looks like. On the first column on the left side of our table, we have there our z values. They are usually written in two digits. So one part would be our whole number and one part would be our tenth digit. There on the top on our first row, we have there our hundreds place of our z value. Now let's find out how to use this table in getting the area under the given z value. Example number 1. Find the area that corresponds to z is equal to 2. This is the same as finding the area between z is equal to 0 and z is equal to 2. Using our interval symbol, z is greater than or equal to 0 but less than or equal to 2. So for our solution, z is equal to 2. First, we're going to express 2 as a three-digit number. So that would be 2.00. So for our two digits, 2.0, we're going to locate this at the first column among the rows of our table. And we have 0.00. We're going to locate this at the top among the columns of our table. First, let's locate 2.0 among the rows here on the first column. So 2.0 is here. Next, let's locate 0.00 among the columns here at the top of our table. So 0.00 is here. And the intersection will be 0.4772. So the area under z is equal to 2 is 0.4772. So if we're going to represent the area using your normal distribution curve, then it will look like this. The shaded region is the area between z is equal to 0 and z is equal to 2. So this is our area, which is equal to 0.4772. Example number 2. Find the area that corresponds to z is equal to 2.47. This is the same as finding the area between z is equal to 0 and z is equal to 2.47. Using our interval symbol, that is z is greater than or equal to 0 but less than or equal to 2.47. So for our solution, z is equal to 2.47. This time, our z value is already in the three-digit number. So we're going to use the first two digits, 2.4, to look at among the rows on the first column. And that would be here, 2.4. The remaining digit is 0.07. We're going to look that among the columns in our table at the top. So 0.07 is here. And we have our intersection, which is 0.4932. So that would be the area under our z, which is equal to 2.47. If we're going to graph using your normal distribution curve, so it will look like this. The shaded region is the area between z is equal to 0 and z is equal to 2.47. So this is the graphical representation of our area, which is 0.4932. Example number 3. Determine the area under the standard normal curve to the right of z is equal to 1.63. Using our interval symbol, z is greater than or equal to 1.63. Now, let's find out the area using the table. First, we're going to locate 1.6 here. So this is 1.6. Then the remaining digits would be 0.03. So 0.03 is here. And the intersection would be 0.4484, and that would be the area under Z equals 1.63. So if we're going to do the graphing, Z is equal to 1.63 looks like this. So this is 0.4484. But then our problem says to the right of Z is equal to 1.63. The unshaded region on the left side of our area is what we are looking for because that is to the right of our Z equals to 1.63. So if we're going to redraw our normal distribution curve, it will look like this. So this is the area that we are concerned for. So how do we find this area? So just simply subtract 0.4484. The area under Z is equal to 1.63 from 0.500. Earlier, we mentioned that our normal distribution curve is equivalent to 1, and half of that is 50%. So 50% is equal to 0.5. So we are looking for the area here. So we're going to subtract 0.4484 from 0.500, or that is 0.5 minus 0.4484. And the answer would be 0.0516. That would be the area here to the right side of our Z equals 1.63. Let's go to example number 4. Determine the area under the normal curve between Z is equal to negative 0.37 and Z is equal to 1.03. Using our interval symbol, Z is greater than or equal to negative 0.37 but less than 1.03. So this time, using our table, we're going to find first the area under our Z equals negative 0.37. The second step is we're going to find the area under Z is equal to 1.03, and then we're going to add the two areas. Now let's find the area under Z is equal to negative 0.37. The first two digit is 0.3. So we're going to find here 0.3. And then we have 0.07. So 0.07 is here. So their intersection is 0.1443. And that is the area under Z is equal to negative 0.37. Please take note that the negative sign here signifies that our area can be found at the left side of our 0-point reference. Now this time, let's go to Z is equal to 1.03. So first, we're going to locate 1.0 here. So 1.0 is here. And then 0.03. So 0.03 is here. And the intersection is equal to 0.3485. That is the area under Z value, which is equal to 1.03. Now let's go on how these two areas look like in our graphical representation. So this is the area of our Z, which is equal to negative 0.37. As you can see, it is found at the left side of our 0 point here at the center. And our area under Z is equal to 1.03, looks like this. We must remember that if the problem states about between two values, we have to consider the signs and the operations that we're going to use. If we have same signs of our Z values, we are going to subtract the two values. If we have different signs of the two values, we're going to add the two values. So this time, since we have a negative and a positive values of our Z, then we're going to add our two areas. For our solution, 0.1443, the area under Z is equal to negative 0.37. We're going to add that to 0.3485. The area under Z is equal to 1.03. And the sum is 0.4928. This is the total area of the standard normal curve between Z is equal to negative 0.37 and Z is equal to 1.03. Now let's go to the application. A soda machine dispenses soda into 12-ounce cups. Test shows that the actual amount of soda dispensed, normally distributed with a mean of 11.5 ounces and a standard deviation of 0.2 ounce. Question letter A. What percent of cups will receive less than 11.25 ounce of soda? For our solution, since our problem did not mention any value of our Z, then we're going to use this formula of Z. So that is Z sub x is equal to x minus mu all over S. So for our given, x is equals to 11.25 ounces. Our mu or our mean is equal to 11.5 ounces and our S is equal to 0.2 ounce, our standard deviation. We're going to substitute these values into our formula. So that would be equal to 11.25 minus 11.5 all over 0.2. And that is equal to negative 1.25. Now, if we're going to use the table to find the area of Z is equal to negative 1.25, that is equal to 0.3944. Less than 11.25 means to the left of Z is equal to negative 1.25. So, we need to subtract the area under Z is equal to negative 1.25 from Z is equal to negative 0.5. Thus, the area of Z is less than 11.25 is equal to 0.500 minus 0.3944 is equal to 0.1036. But we are being asked here for the percentage of our cups. So we need to multiply 0.1036 by 100%. And that would be equal to 10.36% cups. Letter B question. What percent of cups will receive between 11.2 ounces and 11.55 ounces of soda? So since we have two values of our Z, we're going to get the areas under each of these Z values. For our solution, for 11.2 ounces, we're going to use the same formula. That is Z sub x is equal to x minus mu all over S. Substituting our values in the equation, so we have 11.2 minus 11.5 all over 0.2, and that is equal to Z, which is equal to negative 1.5. So using the table, the area under Z is equal to negative 1.5 is 0.4332. For 11.55 ounces, using the same formula, Z sub x is equal to x minus mu all over S. Then we're going to substitute the values into our formula. Then we have 11.55 minus 11.5 all over 0.2. And that is equal to 0.25. Now using the table, we're going to get the value of Z, which is equal to 0.25. And that is equal to 0.0987. But we are being asked for the percentage of cups. So we're going to multiply 100% to 0.5319. And that is equal to 53.19% cups. Question letter C. If a cup is filled at random, what is the probability that the machine will overflow the cup? So we're going to use this value for our x. So for our solution, using the same formula, say sub x is equal to x minus mu all over S. We're going to substitute the values. So that would be 12 minus 11.5 all over 0.2. And the value of our Z is equal to 2.5. Using the table, the area under Z is equal to 2.5 is 0.4939. But then we're going to find out the area which is Z is greater than or equal to 2.5, meaning to the right of 2.5. And that is equal to area of Z greater than or equal to 2.5 is equal to 0.500 minus 0.4939. And the answer is equal to 0.0062. But then we're going to multiply 100%, and that is equal to 0.62% probability. This lecture was based from the following references. They were used for information and for educational purposes only. I give the full credit to the owners. Thank you so much for listening and watching this video. Please don't forget to like and share this to your friends and your classmates. And if you have questions, just go to the comment section below. And I hope you consider subscribing to this YouTube channel. Again, it's my pleasure to create and make video on your math lessons to make your learning journey a wholesome and fun activity. By the way, this is your Sir O. Till next time, God bless and keep safe always. Goodbye.